Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a trigonometric equation with complex numbers. So we have 2 cosine z equals 1 plus e to the power iz, and we're going to be solving for z values. Now in this equation you are probably thinking about some series expansion of cosine and maybe e to the power iz. I'll give you a formula which actually makes this problem a lot easier. And then we're going to look at the result from alpha at the end. Now at this point you can go ahead and make some guesses and check your work, but let's see how this goes. So we have 2 cosine z on the left hand side, and we have e to the iz plus 1 on the right hand side. So are we able to write cosine z in terms of the exponential? And yes, there's a way to do it. So if you just consider Euler's formula, as you hopefully know, e to the iz can be written as cosine of z plus I sine of z. And if you replace z with negative z, because cosine is an even function, you still get cosine of z from cosine of negative z, but sine is odd, so it's going to be a minus sign in front of the sine z. And by adding these equations side by side, you're going to be able to get basically what you need. When you add these equations, I sine z is going to cancel out. We're going to get e to the iz plus e to the negative iz equals 2 cosine z. And then by dividing both sides by 2, we actually get a formula for the cosine of z in terms of the exponentials. But you don't need to divide by 2. Why? Because you have 2 cosine z already, right? So what is 2 cosine z equal to again? It's equal to e to the iz plus e to the negative iz. In our equation, it's given as 1 plus e to the iz. So let's go ahead and set this equal to 1 plus e to the iz. Notice e to the iz cancels out. We end up with something super duper simple, right? We get e to the negative iz equals 1. Now at this point you might be thinking, hey, z equals 0 is a solution, right? Isn't it? Yes, but that's not the only solution. And I'd like to say z equals 0 is a real solution, but there are some complex solutions. And this channel is all about complex numbers. So let's go ahead and look at all the possibilities. And here's what we're going to do to solve this problem. We're going to go ahead and write 1 as a complex number. In other words, we're going to complexify it. So we can do this as follows, since 1 is going to be located right here on the real axis. We can actually go ahead and write it as e to the power 2 pi I. But instead of 2 pi, we could also use multiples of 2 pi. So in general, we can write the 1 as 2 pi n I, where n is an integer. Make sense? Okay, great. So this is really good because now we have e to the power something equals e to the power something else. So that means negative iz equals 2 pi n I. Awesome. You can go ahead and cancel out the I because I is not 0. And then from here we get z equals negative 2 pi n. What that means is that multiples of 2 pi, but when n is negative, this is going to be positive. When n is positive, it's going to be negative. The other way around. So here's what we can do. Since negative n is also an integer, we can go ahead and replace it with like k. Suppose negative n equals k. I can basically write it as d equals 2 pi k, where k is also an integer, because if n is an integer, its opposite is also an integer. Make sense? So basically all the solutions are given by this, and you can definitely replace k with any values including 0. So if k is equal to 0, we get z equals 0, and that gives us real solution. By the way, all the solutions are real. There are no, wait, did I say there are no complex solutions? Well, real numbers are complex too, but there aren't any non-real solutions. I should probably state it that way, right? Anyway, so let's go ahead and see if we can look at this problem from another perspective. So is there another way to approach this problem, right? Well, one of the things you can do is definitely kind of like do a little bit of guess and check. Obviously, when z is real, cosine z is always less than or equal to 1, right? So this should be less than or equal to 2 if z is real, but most of the time it doesn't have to be, right? So in this case we kind of get some type of limitation like e to the iz is less than or equal to 1, which means what, right? That's the problem. So how do you solve for z in this case? So this kind of tells us obviously that z equals 0 is a solution, as well as other ones, because from here we can basically say that, okay, e to the iz equals 1 might give us a solution. But here's the thing. You kind of have to think about both sides. So 2 cosine z equals 1 plus e to the iz. And in this case, since 2 cosine z has to be less than or equal to 2, what happens if it's equal to 2, right? And in this case, this needs to be 1. And that implies that z equals 0 is a solution. But when z is equal to 2 pi k, do you think that would work here? Yes, because cosine z is equal to 1 if that's the case. Make sense? And those are the only values basically that will satisfy our equation. So in general, z equals 2 pi k is going to be all the solutions to this equation. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care, and bye-bye.